Today we're going to be going over how we can simulate a concrete rubble pile using the RBD bullet solver inside of Houdini. Now this is going to be using some Quixel Megascans. Some of them are available for free, so some of them actually require some points to download. So if you want to follow along using the assets that I'm using, you will need a Megascans subscription. So the assets I'm using here are this industrial concrete floor, this broken wall, as well as this concrete rubble pack. These two are free. This one will require you to have a subscription. So if you want to download these assets and follow along, by all means do so. If you want to download these two and then just create your own rubble, by all means go for that as well. So jumping in here, I have a scene already set up with some stuff from the original project. So I just got the two broken walls here, as well as a grid set up for the floor. I also have a bunch of object merges that you see right here, and each one of these are a piece of that broken concrete. So if I go ahead and jump back in here, I can show you how I set that up. Go ahead and jump in. I have a file node that has a bunch of splits as well as some nulls here. So when you load this in initially, you see that we have all of them layered on top of each other. So we want to split them out so we can access each one individually. So I just piped it into a material for later so that they all have the same material, and then a transform so that I can make them all smaller. And then this split node is the key here. So you drop in the split and then you go and select whichever piece you want. So I just went down the list here, and then it's output to a null for piece 1. And then if I hover over this other output, you can see non-selected geometry. So anything that you're not, you don't have selected in this group will be passed on to the next split. And then you can just wire them all through to these nulls and get each piece out individually so that you can access them. Let's go ahead and jump back over to the main scene here. And then the first thing that we need to do in order to create this effect, we need to set up some points so that we can use to spawn all of these rubble pieces. So I have this box that I brought over from the original scene as well. It's just a simple box that's been scaled up in the Y and the scale set to match somewhat of the scene. So from here, we need to create some points, like I said. So I'm going to use a point from volume. Go ahead and drop that in. I wouldn't shift enter this right away because it is quite heavy when you first connect this node. I'm going to go ahead and up this point separation all the way to 10, and now I'll go ahead and wire that up. That way you see we have a bunch of points here. If I go ahead and just deselect that, see we got a bunch of points here and inside of our box. So from here, you also want to randomize their position, because if you look here, they're all just in lines. So we want to kind of randomize that so that they're not all spawning in the same spot. So that looks good. And then I want to actually fuse some of these points together so that they're not so on top of each other. So I'm going to use a fuse because we don't want our geometries being super inside of each other. So we want to get rid of some of these points that are too close. I'm going to go ahead and just up this a decent amount to something like 10, probably work. And then from here, we need to copy all of these objects to each one of these points. The way that we're going to do that is we're going to drop in a for each loop. We're going to loop over each individual point. We also need to drop in a switch node up here, and we need to connect all of our objects to the switch node. So just select them all and then wire them into the switch. And now you can see, if I go to our objects here and select the switch node, I can switch between all of these. So we're going to automate that here in a second, but let's go ahead and wire up our fuse into the for each begin. We're also going to drop in a copy stamp, and this is how we're going to copy each point to each piece to our points. So I'm going to go wire that in here. I'm going to connect up this switch node. So now if I go ahead and take a look at this, you're going to see that we have a bunch of geometries copied to each one of these points. Now, this isn't exactly what we want because we want to have some random rotation in here. We also don't want to have the same object. So if I switch here, you can see I can select which object we have. So I don't want all of the same object. I want to randomly choose one of these objects that we have and copy it randomly. So the way that we're going to do that is we're going to go to this for each, and we're going to create a meta import node. And then from here, we need to set up a formula into this input. So we're going to use the detail attribute because we want to access the meta import node. So the way that we're going to do that is detail, and then we'll type in just like this, the for each meta begin. So your parenthesis and then 2 periods and the slash goes up a level, and then access the for each metadata. Close parenthesis, then we'll do a comma, and then we'll type in iteration because we want to go over each iteration. So every single point will be a new iteration. And then we want to type in a 0 after that. And we'll go ahead and hit enter. And now you can see that we have a different one for some of these points, but a lot of them are all the same after it gets through all 6 of our objects here. So we're going to go back into this. We'll go to the start, and we're going to do a random. So rand, and then just close that parenthesis off. So what this is going to do is it's going to randomize the detail here. So this detail is going to have each iteration. So point 1 will be, or point 0, I guess, will be 0. Point 1 would be a 1, and then it's randomizing based off of that value. So each point is a different number, and that's being plugged into this random, which is then randomizing it between 0 and 1, I believe. So then we need to fit this. So we'll do a fit 0, 1, and then we'll go to the end, comma, and then we want to go between each one of our objects. So 6 objects, so 0 and 6, or 7 objects, whatever it is. And so now as I hit enter here, you can see that we have all of these randomized. So we do have quite a few copies. So if you're questioning whether or not this is actually copying randomly, you can set up colors inside of the original geometry so that you can see which one is which. Make sure you're getting all of them, or you could do it right here. I'm not going to do that because I know that this is working, but I want to have a little bit more control over this as well. So I'm going to go ahead and drop in a null, and we're going to create a seed value from this. So I'll go up here and click edit parameter interface. Go ahead and select these two and just make those invisible, so I don't care about those. And then we'll just select a float, drag that over, and we'll just go ahead and call this seed. And then for the range, I'm just going to set this to 0 and 50, just to give us a little bit larger of a range here. So we'll click apply and accept. And now we can go ahead and right click on this seed value and click copy parameter, and then go back to this switch node. And then we're going to go inside of this this random. So after the detail parenthesis, and then we will go ahead, put a multiplication, and then we will paste relative reference. So now if I click enter here, it's going to be 0 because our default value is 0. So as we change this, you can see that it's now randomizing how our object are being copied. So we'll find one that we like. So maybe not one with so many of these bigger pieces. Like that's bad. It's got quite a few of those. Let's see if we can find something better. Something that we like. That's not too bad. It's got a nice amount of these bigger pieces, but they're all kind of spread out throughout the height of this copy. So that's looking good. So now to get the simulation going here, we can drop in a RBD bullet solver. Go ahead, drop that in and wire that up. And we need to, also set up the ground plane because we want it to affect or not go past our ground. So we'll set up that ground plane. And I just have this grid here that we had set up before as on the origin as well. So it's right where this ground plane is going to be. And you can see this is where the ground plane is, but these arrows signify that it goes on indefinitely. So you can have the solver going all the way over here, and even though it's not on top of this actual plane that's showing, it is still going to have ground being all the way over here. So if I go ahead and play this, you're going to notice that we have some issues. So if I click play, you can see that we have all these not working properly. They're kind of all sticking together. It's kind of treating each one of these different objects as all of the copies as one object. So all of these big pieces that you see right here, it's for some reason identifying them as all one object, which is obviously not what we want. And I'm not exactly sure why it does that. It only does it part of the time. I've got it to work doing the exact same thing without that, or with this same setup, but without it treating them all as combined pieces. So I'm not really sure what's going on with there. I spent a bunch of time trying to figure out how to get it to not do that. Didn't ever come up with a solution of why it was doing it, but I do know how to fix it. So the way we're going to do that is we're going to drop in a RBD material fracture. And before I wire that up into the solver, I'm going to go ahead and select it. I'm just going to go ahead and delete this fracture level because we actually aren't going to be fracturing this. You can if you want to, but I just want to keep these pieces as is. So I'm going to go ahead and just actually go reset our sim and wire this on up. It's going to take a second to calculate because it's going to fracture. So if I go ahead and play right away, you're going to see that this is actually going to work this time. So as they hit the ground, they all, collapse onto each other like they should, but they are fracturing right now. So we want to get rid of that fracturing. If you do want the fracturing, by all means, go ahead and keep it. You can up the fracture levels if you want to add some detail in there, but I don't want any fracturing because these are nice scans from Megascans. So we're going to just keep them as is. So the way that we can go about getting rid of the fracturing, you can't actually delete this fracture level. So if I go ahead and do that and I click play, you'll see what happens. Same issue as we had before, right? So not what we want. So I'll go ahead and add that back in. And once it calculates here, we want to just go ahead and drop this scatter points all the way down to 0. And that's going to eliminate any sort of fracturing that's going on, but it's going to maintain that the solver is seeing each one of these objects as individual objects and not the combined meshes that it was for some reason seeing them as before. So now as I click play here, you can see once they hit the ground here, they're going to all collapse onto each other and there's no sort of fracturing going on, just have these nice big pieces like we want. So from here, we want to actually have this combine with the rest of our scene. So I go ahead and wire this up. I go ahead for OCD's sake, just drag this over here, and we'll go ahead and take a look at this. So if I click play, this is going to go ahead and play, and we'll kind of see some issues that we got going on as it gets further along here. So right here, if I just pause it, you can see that we have our geometry, but it's not actually interacting with the concrete barriers that are around here. So obviously that's not what we want. We don't want them to be clipping inside of the geometry here. So we have to enable the collision on these objects right here. You could also do it with the floor if you were not using that ground plane, but we're using the ground plane that's set on the same space as this grid, so I'm not going to need to worry about that. So we just needed to activate the two concrete barriers as our collision geometry. So the way that we're going to do that is we're going to go up here and we'll do an RBD configure, and we're going to go ahead and wire this merge node into this, and we'll go ahead and select the configure, and we need to go over here to the bullet data and just click activate. From there we need to go into our, and actually you can go ahead and wire up these as well. You will need the other two inputs in order to have the constraints and stuff working for the material fracture if you're using the detail and the fracture, if you're actually enabling fracturing, which obviously we're not, but we'll go ahead and wire it up for our sake right here. So now we need to take the first input here of our RBD configure, and we need to drag it into the fourth input of our bullet solver. You can see there as I hovered over it, it says collision geometry. So we've activated this geometry as being viewable to the sim, and then we've wired it into the collision input of our bullet solver so it knows that that is what we're using as our collision geometry. So now as we click play here, and it starts this sim, you're going to see the collisions that were not happening between our objects here and the big concrete barriers are now going to be taking place, and it works perfectly. See, there it just hit, and it's being stopped by our concrete barriers here. So obviously you want it to, you know, kind of stop moving so it looks kind of like it's actually sitting there. So and let's keep playing just a second. And that actually didn't fully settle, so you could continue on the simulation until all the pieces settle, but this will be good enough for right now. So let's say we want to do an animation and we want to stop this on this frame right here. So the way that we would do that is we go and drop in a time shift, and we need to go and delete this channel right here and just leave it on the frame that we're on. Go ahead and wire that up right here. And now you can see as I scrub through the timeline here, it's going to be frozen on this particular frame. So let's say you want to do a nice little camera animation where it, you know, kind of rotates around like that. This is how you would go about doing something like that. And obviously, if you want to put on the materials and stuff, you could go ahead and just drop in the material nodes before on these two connections right here, and wire up the materials, set those up, and render out your scene. So not too difficult here. If you can get around the issue that I was having with this copying to the points, with them for some reason seeing the geometry all as one when it needed to see it as each individual piece as its own geometry, can be a little confusing to figure out. Like I said, I'm not exactly sure why it sees the meshes as being all one when there's no connections to them, but this is how you get around it. And actually, if I'll go back here to our bullet solver, and I go back to frame 1, and by the way, the blue geometry means that it's active in the sim, so you can figure that out based on that. So if I look through here into our sim, I don't see any that are actually colliding. Actually, yes, this one right here is colliding. So these two are actually inside of each other, and that's fine. I have found, because it seems that once they exit once they are no longer, you know, colliding with each other, they're no longer inside of each other, the sim acts as normal. So not a big deal in this type of a simulation. It's probably a bigger deal with other things, but for what we're doing in this thing right here, you don't need to worry too much about the collisions off the start, because once they start falling, they will be all good. And actually, I did forget to give us a random rotation. So let's go ahead and do that as well. So we'll drop in a transform in between this switch node and the copied points. And then in here, we're going to basically do the same thing as we did in the switch node. So we'll just do a fit 01 and then a rand followed by a detail. And then we'll again access our for each metadata. And then we'll again type in the iteration to grab the iteration number that we're on. Type in 0, a second parenthesis, and then we want to go from 0 to 360. Kind of got cut off there. But yes, this is our full, I think I can, oops, that's not the right thing. So if I look at the full formula here, so you can just go ahead and copy this, and then we'll go to the next rotation and the third one. So your X, Y, and Z, and copy and paste that into all of these. And now we have some random rotation going on. And just since that wasn't working before, let's go ahead and resim, take a look, and see what that looks like. So as you can see, got our collision still. It's got a little bit more randomness and a little bit more accurate to how things would probably fall. And we've simmed all the way through. So now if we go to our time shift, you can see that we have our nice rebel pile right there. So like I said, not too difficult, a little confusing if you don't know how to get around the couple issues there, but hopefully this helped you out. You can use this for all sorts of different things. Get yourself some accurate simulations going on for your piles of debris, whether it's concrete like this, or maybe you're simulating some branches in a forest scene that are on the ground, stuff like that you could use this for. So I got a bunch more Houdini tutorials on my channel. If you are confused at all by what I'm doing here, if you want to learn a little bit more about the material fracture, I just did a bunch of videos on this RBD and the bullet solver. So take a look at those if you're interested in those. As well as I do have some Cinema 4D stuff on my channel as well if you're a Cinema 4D user. But mostly what you're going to find is a bunch of Houdini stuff. And if you're interested in finding out how to texture these things inside of Redshift, I did use Redshift to render out this scene that you saw at the beginning. If you want to know how to do that, if you're confused at all on how to set that up, make sure you guys let me know, and I can do some videos on how to texture megascans or any other assets inside of Redshift. So like I said, hopefully this helped you out. Leave a like and subscribe so you don't miss anything else that's coming from my channel. Do have a bunch more videos that I got in mind, some more stuff on this RBD material fracture and the bullet solver as well. So if you want to learn more about that as well, then I would definitely subscribe so you don't miss it. But thank you guys for watching, and have a good day.